Okay, so this is 1.3 4A pre-cal 30 here. And so I'll do this with you, PC 30 1.3 4A. So we're determining equations. Okay, determining equations. So this original equation, I'll just focus on the first two. Maybe I'll zoom in just a bit. So the first equation looks like this little, almost like a backwards square root sign, okay? So what's happened going from the original to A here? It looks like that, first of all, we want to deal with A and B first, the stretches and the rotations, the flips. So the first thing I noticed that this looks to be flipped around horizontally. Do you guys see that? It's flipped around horizontally. So if we're taking a look at like A, B, H, and K, which parameter flips it around horizontally? Which one is it? The horizontal flip. It is?
B.
B. Yeah, so B is going to be negative something. Okay? B is going to be negative something because it flips around. Now, let's take a look at, since we're on B, let's take a look at the overall width of this one. That is going to be 8 units, right? That's 8 units this way. So what's the overall width of this one? -4 to +4. Oh, that's 8 units as well. So does it look like this thing has stretched horizontally at all? No, it looks like it's the same width. So B is probably going to be -1 then. It's just going to be a flip, or a, I don't want to say a rotation, but a reflection, and it hasn't stretched out or in, so that's going to be a 1, okay? Now let's take a look at A. Remember, A is the vertical stretching, okay? My computer is just lagging here. It might crash on me any moment, so we'll see how that goes. So A, what's the overall height? We're going from 4 down to -2. That's 6 units. 2 to -4. Oh, that's 6 units as well. Okay. So does this kind of like, square root sign, does it look like it's been flipped upside down as well? Is there a reflection that way? It looks like, no, it looks like it's just reflected the one way. So it looks like A is +1. Like it hasn't changed at all in the vertical stretch part. Does that make sense? Okay, so we're starting to build. Now, what we want to do, and this sometimes can be the tricky part, how much has it shifted over? Well, with this reflection, notice that this y-intercept would not have changed, right? So let's see what we have to do to, and again, I'm trying to erase some things here, but my computer is just jamming on me. What do we have to do from this vertex to get to this new vertex? Well, we have to go left 2 units, looks like, right? From here, left 2 units, and then down 2 units. Everybody see that? So H, I'm going to be moving things to the left 2 units, and K is going to be down 2 units. So those are the actual values for H and K. And now to put this all together, I'll go y equals, so what's my A value? Well, it's just 1, so you don't even have to write it. It's just 1, so you can leave that blank. F of, now B is -1, so I'm going to go negative. You can put a 1 there. It's a good idea. Negative, and then X with a second bracket. H is -2, so that's going to be -2 or +2. Okay. And then outside we have -2. That's totally fine for you to write it like that. If you don't like this -1 in there, which, yeah, a lot of times we don't have the -1 in there, you could write it like this, negative bracket, like that. Or you could really just simplify this and go -x -2, right, with no secondary brackets, if you want. Either of those, any of those 3 are great.
So if we were to try and plug those equations into to graph it,
Yeah.
how would we put F in?
Yeah, so the reason why this is just, the original graph is just f of x, because this is not an easily defined graph. It's kind of a weird shape. It's got an ending. So this is like a piecewise function. It's got a portion of a line here, portion of a line here, portion of a line here. That's kind of stuck together.
Okay.
So you wouldn't be able to test this out on the graphic calculator very easily.
And would you be able to solve for it, solve for zeros?
Well, if you knew what f of x was, but if you knew what the actual equation was, but it's like I say, it's a piecewise equation. So that means that this whole thing is made from separate pieces. This is part of this line right here,
Okay.
This is part of this line right here.
Okay.
This is a portion of this line right here. So it's kind of, it's a piecewise function, what's called. We'll talk more about piecewise functions later in the course.
Okay.
So yeah, you can't really put this into your calculator, but
Okay,
good
so
question.
What's the point of f in like the equations that we're writing?
Well, you see, what this is saying is that we don't know exactly what f of x is, but this is the transformed version of whatever f of x is. So it's not being specific to this exact graph. It's just saying whatever the original f of x is, this is all the stuff that we've done to it. You know what I mean? This is all the things that we've done to this original graph. So it's kind of like a general statement. This is how you would describe the transformations to your original graph f of x. Yeah, it's right. If it's a parabola and we give you x squared, then you can do all these changes to the actual x squared.
Yeah.
But you don't have to on this one. It's just
Okay.
just do it to the f of x. Yeah. Okay. Is that enough? I'll let you guys work on the rest of number 4 there. That helps.
Sam said he'd go outside. See?
Wait, that's not real.
You wanna go outside too?